Welcome to the microelectronics group of Nortel Networks. As part of Probe and Test Operations Orientation for New Hires, this video will take you inside the test lab and show you the methods and procedures that our products must follow in order to reach their final destination, our customer. Over the next several minutes, we'll review ESD procedures, probe technology, assembly into package form, factory flow, final test, setup reduction, delivery systems, and Promise, our tracking system database. Let's take a tour. Before we enter the test lab, we must first don static dissipative smock, heel straps, and a wrist strap. We verify that our straps are working here at the test lab entrance, and we sign the ESD checklist each day before going in. The average human body can't feel ESD or an electrostatic discharge below 3,000 volts. Many of our devices can be destroyed by as little as 500 volts. Remember, ESD kills. Now let's take a look at the processing of one of our products as it moves through the facility. The first time we see our product, it's in wafer form. It arrives here in pre-probe inventory, the lab's front end. One of these cassettes, which can hold up to 24 wafers, represents a single batch. The devices are printed on the silicon substrate, and there can be hundreds or even thousands of die on each wafer. It takes over 3 weeks for Mod 4, the wafer fab, to produce just one batch, so naturally we take maximum care when handling wafers. The product is checked for basic continuity and functionality using a prober, like this EG4090, made by Electroglass. The rejected die on each wafer are then inked to visually separate them from the good devices. The batch is then sent to die bank inventory where they await shipment to assembly. It should be noted that probe setups are very exact and the bare silicon wafers are delicate, so it's good practice to give probers a wide berth and to exercise caution around them at all times. From the probe process, the product is then sent to an assembly lab, such as this one, where the wafers are then diced into individual die and mounted into package form specifically designed for our customer's use. Factors including the number of leads a device has, the surface area of the die itself, and the available real estate on a printed circuit board determine its size, shape, and package type. Once the devices are in package form, they return to the test lab and are placed in pre-test inventory by one of our inventory control specialists. Each batch is assigned a shelf location, and it is from here that the role of a test operator truly begins. And that role can best be defined by our mission statement: timely delivery of quality products to our customers. One of the primary tools that an operator uses every shift in order to meet this obligation is Promise, the Process Management and Inventory System. Promise is a real-time tracking database, and it allows the operator to move the batch through the many steps that must occur in order for it to reach its final destination, Ottawa finished goods. Once the batch is continued out of pre-test inventory, it is ready to undergo a final test. Semiconductor devices are tested on one of our test platforms, which are made by such companies as Teradyne, ASICS, and Hewlett-Packard. Each individual tester on the floor is given its own designation, but it is generally referred to by a short form. Teradyne system T01A520, for instance, has the nickname Elm, while T02A520 is called Ash. Each tester consists of basically three parts: the test head itself, where the device is placed, the system's power supply, and the OMI, the operator machine interface, which is something that we all recognize, a workstation terminal complete with keyboard and monitor. A large percentage of our product is tested using a handler. There are two types here at Probe and Test. The first is a delta, which moves devices from tray to tray, as shown here. The second is called an ASICO, and it conveys the devices in tubes. A handler docked to the test head reduces the amount of contact that the operator has with the device and ensures the fastest test method available. A handler also has three primary sections. The input is where the operator can place several tubes or trays which are automatically loaded into the machine. The core section is a chamber where a pick-and-place arm puts the device in the test socket. The core can also be sealed off, which allows devices to be cooled or heated during temperature testing. Finally, there's the output, where the devices are binned according to whether they have passed or failed. Much of our product, however, is NPI, or New Product Introduction, and some of it cannot be tested using automated handling equipment. These devices must be tested manually. The operator, using a vacuum pencil, picks up and places the devices into the test socket. After final test, the operator tracks the batch through in Promise, and after verifying the counts, wraps the batch up. It's important to remember that devices go into trays with the proper orientation because they're removed by automated handlers down the line and placed on printed circuit boards. If they're placed incorrectly, the rework can be costly. Once final testing has been completed, all that remains is for our product to come here, the back end of the lab, where the devices can be inspected for branding, lead integrity, and finally shipped out to our customers. The delivery systems that we use are also the final gate of quality for our products. It is here that everything must be inspected prior to shipment. Delivery specialists are responsible to oversee that this is done properly. Much of the back-end machinery is equipped with some form of vision system. They can be taught to read the various branding on the devices, such as the Systemation ST495. Any non-compliant device is binned as a reject. Another capability that our equipment features is lead inspection. A separate camera is calibrated and trained on the device's leads, and, in the case of this system made by Texas Instruments, it can even be programmed to straighten them. After lead inspection, several package types must be baked to eliminate humidity. The devices are then reeled or stacked in trays, which are then strapped and packed in ESD-safe bags with a desiccant pack and humidity detector. Then the product is placed in a special carbon-lined box, sealed, and the appropriate labeling is affixed. The packing operator then tracks the batch through in Promise, and it is automatically moved to Ottawa Finished Goods, where it awaits acceptance. The product is placed on a designated rack, which will then be removed from the lab by finished goods personnel. The entire process varies from product to product, week to week, which is why a flexible, fast-moving team of operators working in conjunction with engineers and technical support staff is so vitally important. 24 hours a day, 7 days a week, semiconductors move through our line. It takes teamwork to make it flow smoothly, and it takes every one of us to make the team work. This was just a brief tour of Probe and Test. As you've seen in this video, there's a lot happening in the ever-growing world of microelectronics. Customer demands of mission-critical telecommunication solutions is what our business is all about. That's all for now. I'm Dave Whalen.